NAIST began in 1991 as a new type of national university with no undergraduate programs, but with 3 graduate schools focused on advancing the information, biological, and materials sciences that provide the foundation for 21st century society. NAIST uses the Mandara system as an information infrastructure for promoting world-class research in those 3 fields and related areas of interdisciplinary study. The name Mandara refers to the esoteric Buddhist belief that the search for the infinitesimal paradoxically leads to infinite proliferation. Based on the Mandara philosophy of attaining perfect equilibrium, the frontline staff at the Information Initiative Center are configuring the Mandara system as an information processing environment that meets researchers' needs. The concept for the Mandara system is a design built on 3 foundations, with the dynamism of walking around in nature. First, is a cutting-edge research platform for information infrastructure with state-of-the-art information processing equipment. Second, is high mobility, so devices can be freely used wherever information processing is required. Third, is a cooperative distributed processing environment that allows users to make use of network services based on their needs. The Mandara network is the backbone of the Mandara system. Operation of the Mandara system, which unifies systems with an extensive range of functions, is dependent on smooth intersystem communications. The system also needs to support seamless resource sharing, high-definition multimedia communications, and grid computing. Ever since NAIST was founded, the Mandara network has been continuously upgraded to create one of the fastest ultra-high-speed campus networks in the world. Current communication speeds are 100 gigabits per second for the core network and 20 gigabits per second for branch networks. Wireless LAN services of 50 to 100 megabits per second are also available across the entire campus. The Mandara network ensures high-speed internet connectivity with a dedicated 10 gigabits per second connection that enables ultra-high-speed access to major websites in Japan and abroad. More than 4,000 terminals are connected to the network at any given moment. The server room in the building housing the core system for the university-wide information environment system was designed with disaster planning in mind. It can withstand heavy loads and earthquakes, and is equipped with emergency power generators. The air conditioning system is energy efficient and utilizes data from sensors that monitor temperature, humidity, electrical current, and voltage. The container-type data center houses the computing servers for the university-wide information environment system and reciprocal backup systems for other organizations. It is functionally enhanced compared to the server room in the existing building mentioned earlier. In particular, the efficiency of the air conditioning system and the center seismic resistance are markedly superior to those of the server room in the existing building. Large-scale computing servers provide great versatility for handling a wide range of calculation requests, as well as enormous processing power for performing stable large-scale computing. Institute members can use this high-performance computing system free of charge. When using the system, jobs can be added to a scheduler queue suitable for the program by using virtual platforms such as Docker, KVM, and LXC. In addition to the standard method, administrator privileges can be given to users on virtual machines, enabling a wider range of uses and support for applications. A total capacity of 25.4 petabytes of data storage is used for test data, backups, and the home directories of institute members. A hierarchical storage system made up of SSDs, hard disks, and tapes saves power and makes efficient use of hard disks and other resources by only storing data that is actively being used on hard disks. and saving data not being accessed on tape. NAIST engages in challenging research in which a car-sharing system consisting of 3 electric vehicles, established as part of the university-wide information environment system, is viewed as a proxy for society, and physical problems that arise in society are resolved using the intangible force of information. Using the miniature proxy for society established at the university as a model, research, experiments and demonstrations are conducted with the aim of achieving a sustainable society in which information technology modifies people's behavior. This MRI machine can capture images of a patient in either a supine or upright position. This makes it possible to take images of the hip, knee and spinal column in situations where it is important to analyze them in a standing position. Patients with diseases in these joints experience pain when the joints have to support weight in a standing position, but not when lying horizontally. By analyzing the changes that occur with movement in both supine and standing positions, the university's research aids in the understanding and treatment of disease and patient rehabilitation. To support research in a broad range of fields, NAIST uses 3D printers offering a highly precise laminating pitch and support for different types of resin. Printing is possible using heat-resistant and rubber-like resins, in addition to conventional hard resins. The 3D printers are used to create parts for high-performance robot arms, components for wearable devices used in virtual reality, augmented reality and mixed reality research, and IoT devices using ultra-compact Raspberry Pi computers. The Information Initiative Center conducts research on disaster recovery with the aim of ensuring the continuation of its operations. In light of the major disasters that have occurred in Japan since the Great East Japan earthquake struck on March 11, 2011, it is imperative that lessons be drawn from these disasters and countermeasures be taken in preparation for the anticipated damage and casualties from the huge Nankai Trough earthquake expected to occur in the near future. In the case of a major natural disaster, it is essential that disaster medical assistance teams, or DMATs, be able to share information to confirm that the transport of victims and related activities are effectively carried out. To share information in disaster-stricken areas where the communications infrastructure has been destroyed, DMATs must be able to make effective use of functioning land-based and satellite communication lines. This system makes it possible to provide internet access even when the ground-based telecommunications infrastructure has been damaged by an earthquake, tsunami, or other natural disaster. This is done by connecting to communications satellites instead of ground-based communications networks, and by using the automated satellite acquisition system of a VSAT or Very Small Aperture Terminal Earth Station installed in hybrid cars, which provide both mobility and power. The system can be operated using voice-guided navigation and LCD touch panels, which do not require specialized knowledge or skills. In the case of a major natural disaster, DMATs on self-defense force ships would use staging care units or SCUs. But communications systems on the ships are closed networks that cannot provide DMATs with internet access. Here are a diagram and an overview of the multipath network built using multiple wireless devices during DMAT training on July 29, 2017, which was sponsored by the Cabinet Office. It allowed SCUs on a docked self-defense force ship to use a system set up on the dock to provide an internet connection via a satellite link. The multipath network was achieved by extending the satellite link-enabled internet connection system on the dock to the ship's decks using 4 types of wireless connection. It provided high availability because it maintained continual communications by switching to one of the other wireless connections whenever the current connection was cut off. The network extended to the upper deck of the ship was further extended to the DMAT headquarters established on the lower vehicle deck via an Ethernet cable.